Welcome back to my Commodore 64 Memories videos. This is where I look at old Commodore 64 software and some of the technical details behind them. Today we have H.E.R.O, Hero, released in 1984 by Activision. Creator was John Van Ryzen and the conversion by the Softworks. Sometimes known as Helicopter Emergency Rescue Operation. So this is kind of like a really old classic Commodore 64 game where you have to control your helicopter jetpack equipped hero, I guess, and you have to go around the caves and you have to try and rescue people. You've got some dynamite, you've also got, like a little laser gun or something like that. This game always brings back memories because I used to have this game way back in the day. And I was always intrigued, actually, because I was trying to figure out how to use customized graphics on the Commodore 64. And this one seemed, at the time, to be quite colourful. And it got me rather puzzled until I figured out that it was using extended colour mode. So you can see that it's using high-resolution graphics, but it has more variation in terms of background and foreground colours for the high-resolution graphics for the cave system. And this is because it's using extended colour mode. I was asked to have a look at this game by one of my YouTube commenters about how this game was using extended colour mode. So here we are. In C64 Debugging, we can see immediately actually that the top part of the screen is using the EXT mode rather than the standard mode, extended colour mode, basically. We can see that the rest of the high-res bits are set up. It's not a multicoloured bitmap or anything, it's a high-res extended colour mode screen. Now at the bottom we have this raster split and it goes into multicolour standard mode for the rest of the characters down at the bottom of the screen. But it's definitely the game mode area of the screen which is in high-res extended colour mode. We can see that quite plainly. The red bounding boxes, of course, with C64 Debugging show where the sprites are. The laser, or whatever it is, coming from the player is using what looks like a horizontally expanded sprite, and that just gives the sprite a little bit more range as it's trying to zap in front of the player. We could of course also see that the lights, the thing that you have to rescue, the bats and the other enemies, they're also all sprites as well. But to be honest, I don't think that there's a sprite multiplexer anywhere in this. I think it just uses a maximum of the 8 hardware sprites. Here we are now in ICU 64 with Vice emulator, and we can see on the tape version we have this loading screen. The tape loader for the original release anyway is actually quite slow. I think it's using the ROM loader, so it does take its own sweet time when loading the game, and the screen is off as well. I'm warping through the final part of the load now in the emulator at just over 10 times, 11 times normal speed. Now there's this really weird long pause at the end of the tape as well on this particular tape image. And I don't know if this was like that on the original tape release, but that long pause, oh. Well, okay, so the screen is off, but look, in the graphics map debug view, it's actually saying disconnect any other peripherals except cassette unit and reload. But the screen is still off in the emulator, so even if you encountered this error message, you wouldn't have seen it, which is not that useful, right? Let's run through again after disconnecting the disk drive, and then hopefully it will work this time. Just warping through. Yeah, there's the previously loaded bitmap, still in memory. It's quite slowly loading the data that we can see in the memory event viewer there. Very useful for this game, actually. It has a self-playing demo mode, So we'll leave the self-playing demo mode playing because it's easier to debug the game or to visualize what's happening in the game. So we can see in the memory debug view there, we can see that there's actually some updates of the normal color RAM memory, which helps to give these screens some extra color as well. But let's investigate using the debug graphics map, the game view. So even if I set the character set to be the correct character set at 2000 in memory, you can see that C64 Graphics Map View doesn't correctly render what is visible on the screen. And that's because the ICU Debug Graphics Map View assumes that it's using the standard character set mode rather than the extended color mode character set rendering. Whereas the Vice emulator is using, of course, the correct extended color mode rendering. So let's make this window show just the emulator view of the screen memory. Now I want to show and how to visualize basically the character set for the extended color mode. So to do this, I'm going to create a known character set of all of the hex numbers for the low and high nibbles, the low and high 4 bits there. And I'm going to composite those together so that each character has its own unique number, 00, 01, 02, 03, all the way up to FEFF at the end. FF being hex for 255 in decimal, of course. So there we go. I'll check in actually into source control that Python program as well, so you can see how it runs and how it creates the data. But yes, this is what the character set looks like in memory now. Now that I've loaded the character set into Vice, we can view it in ICU C64 Debug Graphics Map. You can see that the characters go from 0, 1, 0, 2, 0, 3, all the way up to FD, FE, and FF characters all the way at the end. And it's very similar actually to the graphics map, a debug graphics map hex value view, but we want to get this character set to be visible on the emulator, because this will, I hope, will make it quite clear what the extended color mode is doing on a real Commodore 64 and how it differs in the ICU 64 graphics map view here. So let's get these windows sorted out. So my character set is loaded into Vice already, we know that. Now we just need to display some data in the emulator so that you can actually see how the extended color mode character set data is rendered. So let's run this program here, and you can see straight away that we've got some color changing bars. So what does this do? Well, this program, first of all, it sets up with 53272.24, which sets up the character set as visible rather than the ROM character set or the H.E.R.O character set. And then it uses 53265.91. This adds 64 to the standard contents of 53265, which is 27. What this does is that it sets the second to last bit. In other words, decimal 64 in hex, it's going to be $40, right? But this sets bit number 6, which is extended background mode on it, or extended color mode rather. I should really rename that in the standard library, shouldn't I? But anyway, the extended color mode extends the number of background colors for the characters when they're displayed on the screen. I then go through a couple of for loops, one to add all of the characters to the top of the screen, and then the other ones to then update all of the characters for the extended color mode values for extended color 0, 1, and 2, as well as the well, it doesn't change the background color, it just changes those extended color modes. That's why we have a static background color for the first 64 characters. Then the next 64 characters are showing flashing colors, and the next 64 characters are showing different flashing colors, and then the last set of 64 characters are showing different flashing colors, and that's because the different registers are being set up with the different color values. Now, you'll notice here, look, the characters go from 0 to 3F, and then 0 to 3F, 0 to 3F, 0 to 3F. So we have 4 chunks of 0 to 3F, and that's 0 to 63 in decimal. So what this means is that when it's using extended color mode, the VIC chip will only show the first 64 characters of the character set. And then each block of these 64 characters, first 64 characters from the character set, the background color is customizable, of course. The foreground color, which is actually the high resolution pixel, of course, picks up its color information from the normal color RAM memory. But the background color picks up its background color information from the extended color registers. So that's why the extended color mode has a reduced number of characters that can be visible from the character set, the first 64 characters from the character set. The rest of the characters that are in the character set memory, of course, in that block of memory, can still be displayed if you switch away from extended color mode, and if you switch into standard multicolor mode, for example, you can use the rest of the characters that are up higher in the character set. So that it's not wasted memory as such. It's just that only when you're in extended color mode, it will render just from the first 64 characters. So let's put a rem in front of that poke, which turns on the extended color mode, and you can see what it looks like without extended color mode. So you can see straight away that all of the characters are visible. All the characters from 0 to FF are visible, but there's no flashing background color, and that's because, of course, extended color mode was not switched on. So updating the background color registers has no effect. And of course, switching off the customized character set by remming that 53272 poke just displays the normal ROM character set as you would normally expect, right? Let's add pokes for the color RAM poke, right? So 555296, yeah, is definitely the color RAM. So we'll add an extra color for the foreground pixels, the actual non-transparent pixels, the opaque pixels, and then the background colors will have the extended mode color registers being updated as well. So here we go, nice colorful characters, and then the extended color mode gets switched on, extended character color mode gets switched on, and there you go, you can see straight away that we have nice colorful opaque pixels for the foreground pixels, and then for the background pixels, of course, it's updating those color registers. So there we go. That's a quick run through of how this game is using extended color mode and how extended color mode works with the Commodore 64 and its very flexible VIC chip. I hope you found that useful on how extended color mode actually works. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. Take care, have a great day, evening or night, wherever you are.